today we are going to learn lesson number 3, which is conic section. This time we are done with circle and parabola, and we will now be moving on the ellipse. In this lesson, you are expected to define ellipse, illustrate ellipse, solve equations involving ellipse, and determine the equation of the different kinds of conic sections. The last two objectives will be tackled on our next video. When you cut a cone at an angle, you can form a closed curve which is oval in shape or looks like a square circle. This shape is known as an ellipse. Notice that as you rotate the plane, you can form various ellipses. Just like the circle and parabola, we also have real-life objects representing ellipses. Take a look at the figures here. So grapes are real-life examples of ellipses because it's an oval shape just like an ellipse. Grapes also are a significant example for our world because we eat grapes. On the other hand, football is a real-life example of an ellipse because it's shaped like an ellipse, and if we were to trace, it would come out as an ellipse. This is a significant example to our world because football is the main American sport. For this lesson, we will proceed in the discussion of the third kind of conic section, which is called the ellipse. Ellipses, which is commonly described as oval shape, have significant purposes not just in mathematics but in other fields as well. When a plane intersects a double nap cone and it is not parallel to any generator, the curve formed is an ellipse. Ellipse is considered to be the set of all points on a plane such that the sum of the distances of its points from the two fixed points is constant. The two fixed points are called the foci, or singular is focus. Ellipse has two axes of symmetry that is called the major axis, or also known as the principal axis and focal axis, and the second is the minor axis. The major axis is longer axis which always contains the foci, vertices, and center of the ellipse, while on the other hand, the minor axis is the shorter axis which is also perpendicular bisector of the major axis. In an ellipse, the foci are always inside the ellipse and are contained by the major axis. The endpoints of the major axis are what we call the vertices, which are represented by plus and minus a, while the endpoints of its minor axis are called the co-vertices, which are represented by plus and minus b. Another part of an ellipse is its center. The center of an ellipse is the intersection of the two axes of symmetry. This is the midpoint between the two foci and also the midpoint between the two vertices. A chord passing through a focus of an ellipse which is perpendicular to its major axis is what we call the latus rectum. And on the other hand, a line outside the ellipse that is parallel to the minor axis and has the same distance from the vertex like the focus is what we call the directrix. Since an ellipse has two foci, there are also two latera recta, or the plural of latus rectum, and the two directrices, or plural of directrix. Okay, so other than that is that we need to know that an ellipse can be classified as horizontal or vertical ellipse. An ellipse that is horizontal is if its major axis is the x-axis or it's parallel to x-axis. So, diba, we're looking on the image here, you can see that the major axis is on our x-axis. Remember the x and y in the rectangular coordinate plane, okay? So other than that is that an ellipse is vertical if its major axis or the longer axis is in the y-axis or is parallel to the y-axis. Similar to other conic sections, ellipse has its own general and standard form. Let us now discuss the following forms. So we have the general and standard equations of an ellipse. First is the general form of an ellipse where A, B, C, D, and E are constants. So if the ellipse with the center at the origin, we have the general form as ax squared plus by squared minus c is equal to 0. While if the ellipse is located at the center at hk, so our general form is ax squared plus by squared plus cx plus dy plus e is equal to 0. Once again, remember that the a, b, c, d, and e are constants. Okay? So on the other hand, the standard form of an ellipse where h and k are the coordinates of the center and a squared refers to the square of the vertices and b squared refers to the square of the co-vertices. So we have the ellipse with the center at the origin as x squared over a squared plus y squared over b squared is equal to 1. The other one is that x squared over b squared plus y squared over a squared is equal to 1. As you can observe, the denominator or the a squared and b squared only interchange. Okay? So, lastly is that the ellipse with the center at hk. So, for horizontal is that we have x minus h quantity squared all over a squared plus y minus k quantity squared all over b squared is equal to 1. While for our vertical axis is that x minus h quantity squared is equal or all over b squared plus y minus k quantity squared all over a squared is equal to 1. So similar to ellipse with the center at the origin, you can see that the denominator only interchange for the horizontal and vertical ellipse. Let us now proceed in the transforming the equation of an ellipse from general form to standard form. Let us first have the case number 1. So for case number 1 is that if the center of an ellipse is at the origin, so we simply need to follow 2 steps. First is to move the constant term to the right side of the equation, and second is to divide the whole equations by the constant term. So for example is that we have for number 1, 4x squared plus 9y squared minus 36 is equal to 0. So first is to move the constant term to the right side of the equation, and the constant term is negative 36. So from negative 36, it became positive 36. So we have now 4x squared plus 9y squared is equal to 36. Then the second step is for you to divide the whole equations by the constant term. So all over 36. So we have 4x squared divided by 36. We have 1 over 9x squared. Next is 9y squared divided by 36 is we have 1/4 y squared, and of course 36 divided by 36 is simply equal to 1. So we simply need to simplify our equation. So for our final answers that we have x squared over 9 plus y squared over 4 is equal to 1. We now transform the equation from the general form to the standard form. Okay, so let's have another example. So for number 2, we have 25x squared plus 49y squared minus 1225 is equal to 0. Once again, we need to transform the constant term to the right side of the equation. So we have 25x squared plus 49y squared is equal to 1225. Second is to divide the whole equation by the constant term. So our constant term is simply 1225. So all over lang po natin sila lahat. So when we simplify, we have now x squared over 49 plus y squared over 25 is equal to 1. Same on the step that we did for number 1. Let us now move with number 3 example. So we have 169x squared plus 144y squared minus 24,336 is equal to 0. Once again, transpose or move the constant term to the right side of the equation. So from negative 24,336, it became 24,336. Next is for us to divide all the equations, or the whole equations rather, by the constant terms. So 169x squared divided by 24,336 is equal to x squared over 144. Next is 144y squared divided by 24,336 is equal to y squared over 169. And of course, 24,336 divided by 24,336 is simply equal to 1. So we have now the final answer for example number 3. The next case that we need to consider is if the center of an ellipse is at HK. So we need to follow several steps. First is, of course, we simply need to move the constant term to the right side of the equation. Second is to group the terms with the same variables. Third is to extract the common factor in each group. Fourth is for you to create the two perfect square by completing the squares. Remember that we already discussed, or you already know how to complete the squares of a given polynomial. Next is to keep this statement true. The product of the common factor and the last term of the trinomial is added to the right side of the equation. Fifth is we need to simplify both sides of the equation, and lastly is to express the whole equation by the constant term. So let's have example. For number 1, we have 3x squared plus 2y squared minus 6x minus 12y plus 15 is equal to 0. So first, we move the constant terms. So from positive 15, we have negative 15 now. Next is we group the terms with same variables. So same variable of x and same variable of y. So we have quantity 3x squared minus 6x plus quantity 2y squared minus 12y is equal to negative 15. Next is we need to factor out or extract the common factor in each group. Actually, learning this on grade 8 or common monomial factor, we need to include the x since both sides have, or both terms have x. However, we simply need to use the constant, of course, okay? The common factor, only the constant. So the common factor of 3 and 6 is 3. So we have 3 multiplied by quantity x squared minus 2x plus 2 multiplied by quantity y squared minus 6y is equal to negative 15. So next is creating the two perfect square by completing the squares. We already know this on how we're going to find the third term or the last term for the given trinomial, okay? So of course, we need to divide the second term, only the constant term of course, by 2. So negative 2 divided by 2 is negative 1. So we need to find the square of negative 1. So negative 1 times negative 1 is 1. That's why the third term is y. Next is how do we get 9? So the second term is negative 6. Okay, so negative 6 divided by 2, that is negative 3. And negative 3 squared is simply equal to positive 9. So the last part is that we need to add, of course, the last term of the trinomial to the right side of the equation. But as you can see on the given, we add 3 and 18. Why not 1 and 9? That is because we simply need to multiply 1 by 3 and 9 by 2. So 3 times 1 is equal to 3 and 2 times 9 is equal to 18. That's why we add 3 and 18 on the right side of the equation. So following our steps in simplifying both sides of the equation, we have now 3 multiplied by x minus 1 quantity squared plus 2 multiplied by y minus 3 quantity squared is equal to 6. So divide both sides. By simplifying, we need to divide both sides, or the whole equation rather, by 6. So we have now 3 divided by 6, that is 1 half. Okay, then 2 divided by 6, that is 1/3. So in simplifying, of course, we didn't write the 1, but instead, ito na po siya, we have x minus 1 quantity squared all over 2 plus y minus 3 quantity squared all over 3 is equal to 1. For number 2 example, we have 16x squared plus 25y squared plus 96x minus 50y minus 231 is equal to 0. Again, our first step is to transpose or to move the constant term to the right side of the equation. From negative 231, it became 231 or positive 231. Next is we need to group the terms with same variables. So same x, same y. So we have 16x squared plus 96x plus 25y squared minus 50y is equal to 231. Next is of course to extract the common factor in each group. The common factor is 16 for the x and 25 for the y. So we have 16 multiplied by quantity x squared plus 6x plus 25 multiplied by quantity y squared minus 2y is equal to 231. Next is to create the two perfect square by completing the square. So of course, to find the last term for the trinomial, so we have 6. For the first one, we have 6 divided by 2, that is 3, and 3 times 3, that is 9. So we have the third term, 9. Next is how do we get 1? That is negative 2 divided by 2 is negative 1, and negative 1 times negative 1 is simply 1. So next is we need to add, of course, the last term that we get on the trinomial to the right side of the equation. So instead of adding 9 and 1, we need to multiply 9 by 16 and 1 by 25. So we get 144 and 25. So we have 231 plus 144 plus 25. So by simplifying, we have now 16 multiplied by x plus 3 quantity squared plus 25 multiplied by multiplied by y minus 1 quantity squared is equal to 400. Okay, the next part is to divide the whole equation by the constant term, which is 400. So with that, we can now have the answer of x plus 3 quantity squared over 25 plus y minus 1 quantity squared over 16 is equal to 1. Earlier, you learned how to transform the equation of an ellipse from general form to standard form. This time, we need to transform the equation of an ellipse from standard form to general form. For our case number 1, we need to follow 3 steps if the center of an ellipse is at the origin. So, we have for step number 1 is for you to determine the LCD of the expression. Step number 2 is to multiply the whole equation by the LCD, and step number 3 is to write the equation in general form. So let's have example. For number 1, we have x squared over 4 plus y squared over 1 is equal to 1. So in this equation, we know that the LCD of 4 and 1 is 4. Of course. Next, so since 4 is the LCD of the expression, you need to multiply the whole equation by the LCD. So in multiplying, of course, in applying your knowledge in multiplying this polynomial, so we have 4 multiplied by x squared, that is 4x squared. Divided by 4, we have x squared. Next is 4 multiplied by y squared, that is 4y squared, divided by 1, that is 4y squared. And of course, 4 times 1, that is 4. So we have now x squared plus 4y squared is equal to 4. Next is to write the equation in standard form. So considering the standard form, we need to move the constant term from the right side to the left side of the equation. So we simply have now x squared plus 4y squared minus 4 is equal to 0. So that is now our answer. As simple as that. Next, let us try for number 2. We have x squared over 25 plus y squared over 9 is equal to 1. So find first the LCD of 25 and 9. And that is 225. So we have to, or we need to multiply the whole equation by the LCD. So 225 multiplied by x squared, then divide it by 25, that is 9x squared. Next is 225 multiplied by y squared. The product will be divided by 9, so the answer is 25y squared. And 225 multiplied by 1, that is 225. So we have now 9x squared plus 25y squared is equal to 225. Next is to transpose the constant term from the right side to the left side of the equation. Finally, we have 9x squared plus 25y squared minus 225 is equal to 0. Is for number 3. We have x squared over 4 plus y squared over 7 is equal to 1. Once again, what is the LCD of 4 and 7? Okay, that is 28. Make sure, or this is just a reminder that not all the time that when you multiply the denominator, the result will be the LCD. Remember, not all the time. For example, we have 2 and 4. When you multiply 2 and 4, that is 8. But 8 is not the LCD of 2 and 4. Kasi ang LCD nila is 4. Kasi 2, 4, 6, 4. Tapos 4, 8, 12. So, ang pinakamababa na magkamukha sila is 4. Okay? So, for number 3, ang case kasi is that when you multiply 4 and 7, that is 28, which is their LCD. Basta remember na hindi po sa lahat ng pagkakataon ay pag pinag-multiply mo sa denominator, yun ang kanilang LCD. Okay? So following the steps that I told you earlier, so the result will be 7x squared plus 4y squared is equal to 28. Then simply transpose the constant term from the right to the left side of the equation. So we have the final answer, 7x squared plus 4y squared minus 28 is equal to 0. So for our second case is that if the center of an ellipse is at HK, so we need to remember these 5 steps. First is determine the LCD of the expression, multiply the whole equation by LCD. Third is to expand each binomial. Fourth is to simplify both sides of the equation. And lastly is to write the equation in general form. So let us have example. So for number 1, we have x minus 4 quantity squared all over 10 plus y plus 5 quantity squared all over 7 is equal to 1. First is to find the LCD. The LCD of 10 and 7 is 70. So we need to multiply 70 on the whole equation. So we have 7 multiplied by x minus 4 quantity squared plus 10 multiplied by y plus 5 quantity squared is equal to 70. Next is for us to expand the binomial. When we expand x minus 4 quantity squared, we can use the FOIL method or the shortcut method that I told you last time. So we have 7 multiplied by x squared minus 8x plus 16 plus 10 multiplied by quantity y squared plus 10y plus 25 is equal to 70. Next is for you to simplify both sides of the equation. Of course, you need to multiply 7 on the whole equation or in the whole trinomial. So we have 7x squared minus 56x plus 112 plus 10y squared plus 100y plus 250 is equal to 70. Next is you need to transpose, of course, the constant term to the right side of the equation to the left side. So we have now 7x squared minus 56x plus 112 plus 10y squared plus 100y plus 250 minus 70 is equal to 0. The next thing is for you to arrange, of course, the equation in general form and combine like terms if possible. If you need to add add or subtract or perform operations on all the constant term, just do it. So for that, for performing the operations, we have now 7x squared plus 10y squared minus 56x plus 100y plus 292 is equal to 0. And that is now our final answer. Second example is that we have x minus 1 quantity squared over 6 plus y minus 0 quantity squared is equal, or all over 8 is equal to 1. So once again, we need to find the LCD of our denominator, which are 6 and 8. And their LCD is 24. So divide or rather multiply 24 in the whole equation. So we have 4 multiplied by x minus 1 quantity squared plus 3 multiplied by y minus 0 quantity squared is equal to 24. So we need to expand the each binomial. So just a review for our discussion last time, of course, we can use the FOIL method or the shortcut method. Okay, so we have now 4 multiplied by x squared minus 2x plus 1 plus 3y squared, since the last term in the given binomial is only 0. Okay, is equal to 24. Next is you need to multiply 4 by the whole trinomial. So we have 4x squared minus 8x plus 4. That is actually in the distributive property or simply multiplying. Okay, so plus 3y squared is equal to 24. Next is for you to transform or transpose rather the constant term from the right side to the left side of the equation. Then simply arrange the equation. So we have 4x squared plus 3y squared minus 8x minus 20 is equal to. So based on my observation, I can conclude, or we can conclude, that transforming equations of ellipse from general form to standard form and vice versa will take time. This doesn't just test your mathematical skills, but also your critical skills and patience. So with that, you deserve a big clap for your achievement. Congratulations! And now, we are going to learn how to graph ellipse on our next video. So once again, thank you for listening and God bless.